So yeah, the title is slightly different because there's a funny story there, because usually you send your conference proposal about 4 months in advance, and sometimes you forget a little bit what you were going to talk about, which is exactly what happened. So I figured it out because more or less I know the plan, and this talk is a bit special because it's more about plans and how to try to see ahead than just the normal details. So this is why this is mostly the same title, actually, because the never-ending story of package tools is more or less that we have the system that is in production, and we have to keep evolving and not break things too much, so that users, well, both of them keep using OpenBSD, actually. So there and back again, the idea is that sometimes you try to change stuff, and sometimes it fails. In that specific case, about a year ago, I broke package.head intentionally. Like at some point in time, you try to use package.head, and either you had all package tools and new packages and it didn't work, or you had the new package tools and all packages and it didn't work either. Like this is what you got on 6.0 when you try to install an old package. It was telling you that actually the file that you had was a completely unsigned package, which was completely false because it was signed, but with real tools. So this doesn't happen very often. There is a very good reason for that one, and I'm going to go into details in that particular instance, and then I'm going to talk about why this had to happen and why I'm trying very hard for it never to happen again, hopefully. So what actually happened in that case is that we changed completely the way signature worked in incompatible ways. And so all tools couldn't cope with the new one, which is always expected. Like you had some functionality and then you discover that it doesn't work with all tools. Yeah, sure. But the old ones didn't, the new tools didn't work with the old package, which is a bit new, actually. All style signatures, so if you want to look at the details, you're going to find it in the history of OpenBSD, since it's no longer the case. Okay, the basic idea is that we want to be able to install packages on the fly, so we checksum every file, store the checksums inside a manifest file, a packing list, and the packing list itself is signed. This has, hey guys, I have a picture here. Yeah, probably. I have a picture here on that one, so it's definitely yours. Thank you. So the benefits are that you get on-the-fly checks. You can stop extracting an archive before the end without losing any security. There are some drawbacks as well. One of which is that you have to rewrite the package for signing, which used to be real slow because you had to unpack everything, sign the packing list, and put everything back again. I'll talk about that more later, probably, if I don't forget. And the main drawback here, you have to pass everything to GZip first. Welcome. Hello. Yeah, well, everything does not work. Yeah. You have to pass everything to GZip or some kind of GZip before you check anything. And once you start looking at the unpacking code, you realize that it's almost impossible that this code is safe. That there have to be bugs in the Z library, in any version of the Z library. And, well, you could be thorough and try to edit it and try to fix it. But you can also be lazy and say, okay, who gives a fuck? We're going to get rid of that. So, new deal, new style. We are going to store the signature itself outside GZip. so that we get rid of that issue. Because then we are never going to pass any unchecked information to unpack. And of course, we still have to trust some people. We have to trust our fellow developers to write packages that aren't full with Trojans and everything. But this should happen, usually. And okay, then we don't care if a gzip code is completely broken because we're only passing trusted data to it. It works. Side note, which is important for the rest of the talk, we are not actually extending anything. Like if you look at the gzip format, there's actually a command field which we are using to put our signatures so that it still appears to be perfectly normal gzip files from the outside. If you don't have any package tools, you can still download an OpenBSD package and it will look as a perfectly normal gzip tar file, even though there are some very interesting things going on inside it. So it's a typical signature under the new scheme. Like if you look in the comment field of any OpenBSD package on the mirrors these days, you're going to see something like that. The interested command part is tedious fault. I don't think it's in the room, but yeah, well, it doesn't matter. It's just the way that Signify is producing signatures. It's going to tell you that it's using that specific key. Like we don't really have any certificate, chain, trust under OpenBSD. We don't really care about that, and it's complicated and it gets wrong all the time. So basically, any key that's installed in the right directory is going to be considered as a valid key, and that's it. So it's outside what I'm doing. I'm not the hero for that one. And then we have a list of keywords. Just so because we know that things are going to change at some point, so we have to provide for the future. Like here, we're going to say that we are using this algorithm for now. There was some discussion with Nadi, like which algorithm is the best for us. Like we want to have something which is reasonably small, 256 bits, is enough. But SHA-512/256 is apparently the best way to do checksums in a standard way these days on modern architectures. And then we have block sizes, because we still want to be able to extract stuff on the fly. So looking at packages, we decided that 64 kilobytes was probably the right size for each block. So this is a major departure from what was going on before. As we no longer checksum individual files, we just checksum part of a compressed gzip stream. And as soon as it's actually checked to be okay, to have the right signature, we can pass it to the unpacker. As far as I know, it's perfectly safe, unless someone manages to break one of our cryptographic algorithms, of course. So why does it break? The former version of signatures in package add was much more friendly from a coding point of view, because everything was done inside the package add proper. So you could have decent checks and decent error messages. Like you unpack the packing list and you see whether it's signed or not. And you can even ask the user whether they want to add an unsigned package or not. Now with the new one, package add no longer knows anything, well, mostly, about signatures. It passes everything to an outside program, Signify, which is going to check the archive. And it's all or nothing, like Signify is going to give you an error message that says, I haven't found any signature, or I haven't found any valid signature. And in that case, that's all that package add has to say about it. Hence the message. Well, this was the first version of the message. It's a bit of a stupid message. I stumbled upon something similar during my last vacation. like, I don't know if you can really see on that picture, but this is concrete, right? And you have this sign that says forbidden grass. So this is a kind of an error message that doesn't mean anything in that case. So breaking things was a conscious decision. Usually we try not to break things. But in that case, we decided, even though there is no security hole in GZIP for now, that it was best to thoroughly deprecate the old signature process and only support the new ones. After all, this is OpenBSD, so usually when we have a choice between more security and more usability, we decide to err on the side of security, as usual. This kind of stuff actually happens all the time. Yeah, that's the one. No? What did I do? Oh, shit. Sorry. Yeah. We do change internal details of packages, ports, about every 2 months. And this is the one case in about 10 years that users noticed anything, that we had to actually break compatibility in that manner. As you probably know, if you're in this room, when we do releases in OpenBSD, they are usually supported up until 2 releases afterwards. So that means for a year, you are going to be able to work with OpenBSD, and then you have to upgrade all the time. Actually, this is not true for packages in general. If you're working with package tools, usually you're going to be able to play with all packages that date back 5 or 6 years. Like we have keywords that change. And most of the time, I try to keep supporting them for a much longer period. The idea is that if we can, we shouldn't break backward compatibility as long as it's not too complex. And this happened maybe 12 years ago, back when I was starting on package tools, more or less. And at that point, things were evolving really fast. So it became a case of meta-programming, like you have to have some infrastructure so that you are resilient to change, to unwanted change. So at that point, I added a specific class for all keywords in the packing list, right? Specifically, very intuitively named all. And I've seen no reason to get rid of that structure, and usually I clean it up every 5 or 6 years. Like I look at any keyword in that list, and if it's been there for over 5 years, I usually completely get rid of that, because everybody who has all packages that did back that far usually has had time to upgrade, and he's seen repeated messages that this is an all-compat keyword and blah, 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 you should update and everything. So I'm going to talk a bit about the development process and the design guidelines in general. As some of you probably know, when you do some OpenBSD stuff, we do it by remote most of the time, but we meet once, twice a year to do stuff in person. Like, this was the last hackathons that we had in Paris. Well, it was so long ago, time passes. Like probably 10 years ago. And it looks like this. We put a lot of developers in the same room, and we hack together, we joke together. We do lots of stuff together. This is also from a hackathon, but a more private one with only a few select people invited to a secret place in the middle of France, with mostly cheese and stuff to drink, and a bit of, other stuff to eat. Sometimes there is cool, sometimes. Well, Actually, I have another way to look at hackathons, specifically ports hackathons, where I meet my fellow developers, which looks more like this. Like, I have my colleagues and friends, and I just observe them trying to make their way through the ports tree and trying to fix things, trying to make things work. Is there laundry somewhere in this room? Yeah. Like that, yeah. He's a prime example of a guy who sometimes acts dumb on purpose so that I don't get to be to have too much of a hero complex, and that I have to fix things so that they can understand what's going on. And this is very important, guys. I'm saying it as a joke, yeah, and this is really important to have some feedback about what you're doing so that you don't go in a crazy circle and that you don't write stuff that is impossible to understand for anybody. There's also the challenge that, for real, ports work is hard to do. Like, you are solving hard problems. Like, updating stuff can be difficult. We are dealing with massive amounts of code. This day we have something like 30 gigabytes of packages, and everything has to keep working, and there are exceptions all the time. Well, some of them could be avoidable, like when you've got Ed Barrett maintaining Tech Live, for instance. You know that something wrong is going to happen. But apart from that, yeah, well, very, very good for keeping me in check and making sure that my design is sound and possible to change by other people. So let's talk about more personal stuff, like my actual work environment. For real, this is my preferred work environment. So, Budapest. Yeah, this is Budapest, obviously, for those of you who have been there. If you haven't, if you go through Budapest, you definitely have to go to the baths. That's completely amazing, out of this world and everything. And this place, not Budapest proper, but the bath itself is probably where I do my best work. Like when you've been coding for a while, I think that sometimes you have to dive deep into the code, and then you have to step back and think about what you're going to do next. Because these days, writing more code in packaged, it's very easy. I know the code mostly by heart, but I'm lazy. I don't want to write new code. And also I know that every time I add some new code, I'm going to introduce some new bugs. The only code with no bugs is no code at all. So being away from the keyboard and not writing code, just thinking about stuff, this is something that's really important for every aspect of a major project. If you lose yourself too much in the detail of the codes, you're not going to see the big pictures, and you're going to miss opportunities for optimization and new stuff. Like those signatures, they happen mostly by accident, the new ones. At some point, I was looking at gzip, and we were trying to fix something. I was trying to what was I trying to? Yeah, I was trying to see if I could use some specific streaming gzip algorithm which would compress better and which would work with rsync. And I realized that there were about 5 different patches for different versions of the Z library, and none of them were applicable to us. And then I realized what a mess this was, and I realized that gzip was basically broken, and so that we had to put signatures outside, and then everything happened. The code is trivial. The main idea is that realize there is a problem somewhere, and then you will fix it. Actually, most of the core developers of OpenBSD follow that precept, some of them better than others, like, for instance, our fearless leader, who is spending lots of time outdoors instead of at the keyboard, and so he's a top-notch developer because of that. And you have to keep giving money to OpenBSD so that we can keep having hikes and hackathons and everything, and so that we can think beyond code and actually make some good designs. If you want to hear more about that, you'll have his talk on tomorrow. I guess he's going to talk about Pledge. If you don't know about Pledge, you should go and see this talk because it's really awesome for lots of reasons. Back to me. I can't always be in Budapest. I guess that Robert would kill me at some point, of course. So I have reproduced the same environment at home. Yeah, it's a bit easy for various reasons, and well, there's actually a very interesting detail here. It's a bit shy, so it wanted to be fuzzy on the picture, and I convinced it to be on a better picture. So this is my inspiration. I keep this in the bathtub so that when I take a bath, I have to think about the OpenBSD and to fix more stuff. And yeah, I'm saying all this in terms of a joke, but that's for real. When I say that some of the best ideas and some of the best things that we have in our package tools have been done in a bath, that's true. The last one, which I'm going to talk about at the end, came to me while I was taking a bath. Seriously. Let's talk about some specific topics in package.add, a few of them. Yeah, I'm going to put that on full. Sorry. So this is all about change. This is the part which is talking about the never-ending story of package tools. Sometimes we have to revisit some decisions. Some of them were not mine at all. Like when I decided to rewrite the package tools, we already had the package format, which is mostly a gzip tarball. There are some pros and cons for it. The most interesting things about it is that it's a perfectly standard format. So if you take a package from OpenBSD and you have to look at it on another operating system, you will be able to look at it for the most part. It might be a bit complicated on Windows, but you can probably find tar on it as well, with luck. I don't give a fuck. Last time I ran Windows was about 5 years ago, I guess. But still, every time that we are going to do something to our tools, we are going to have to question whether or not we should change stuff. And sometimes, some details are going to change, while the outside appearance is going to stay the same. I already talked about signatures, like you have actually a significant command field in the gzip headers these days. Let's talk a bit about chunk gzip, which is something I was aware of about 15 years ago, but back when we did the first version of signing, Nadi reminded me of it. Like, you can actually pick up a file, gzip it, pick up a second file, gzip it as well, and concatenate both files together, and you will end up with a valid gzip file. Like you pass it to gzip, and it will just unpack the first stream, then the second stream, and unless you specifically ask for it, you won't see the difference. It's exactly as if you had one single gzip file. So this helped a lot at first for all style signatures. Instead of having your whole package as one gzip file, needing to extract everything, sign the packing list, and then repackage everything, you can just do your package in two parts. You're going to create the beginning of the tar archive with just the packing list. You compress that. Then you take the rest of the stream and you compress it separately. So you have one gzip with just a packing list, the other gzip with everything that goes after it. And when it comes time for signing, you just unpack the first part, sign it, compress it again, and then you just copy the rest of the file. You don't have to gmzip and gzip it again. We went from, I guess, 4 hours for signing a full snapshot, full package snapshot for OpenBSD, to about 30 minutes on the same machine using this technique. What's the relevance these days? Because, as you know, we no longer put the signature inside gzips. We still use this technique for other reasons. Like when we want to transfer packages, we actually put them inside a chunk gzip with 8 files for each chunk, so that our sync is happy with it. What's going on here is that a few years ago, and again, because we already have checksums for every file inside an archive, we decided to depart a bit from the usual tar format. Well, it's still a perfectly normal tarball, but the order doesn't match the packing list anymore. These days, we have the packing list, which lists every file inside the archive, and we have the archive proper, which does list files out of order, with the most recent files first, and the files that didn't change at the end. So that when you upgrade your machine, instead of unpacking everything from every tarball, you are only going to enter the files that do change inside your package. And as soon as it finds that the remaining checksums are just the same, it will be perfectly happy to skip the end of the archive and to tell you that the upgrade is complete. For most packages, this is not a significant win. Like sometimes you are going to get 20%, 25%. There are some exceptions too. If you look at stuff like TechLive, for instance, where there are lots of very small details that change, but that are completely insignificant compared to the sheer size of the package. I think that the TechLive package these days, when you put everything together, you get 1 GB of files. And on each update, with this technique, you get to extract maybe 5% of the TechLive tarball. So instead of 1 GB, 200 megabytes, no, yeah, at most. That's a huge win. And it also works with rsync these days, because we chunk files from the end, and we no longer store any timestamp inside the tarball itself, obviously, they are in the packing list. And so, in the end, you are going just to transfer the new chunks at the start of the archive that change, and the rest, rsync is going to say, as it's supposed to do, okay, it didn't change, so let's not transfer it. The only reason this kind of stuff keeps happening in OpenBSD is because we look at stuff that we are doing and that we are designing stuff to be fast. If we didn't have old-style signatures, we wouldn't have thought about chunk gzip, and then none of this would have happened, actually. Next case study, the repository format itself. One peculiarity of OpenBSD is that we don't have any index for packages. Well, we do have tools that you can use, for instance, to locate files. We have make package locate DB, which gives you a specific package, which is basically a locate database of every file in every package. But the package tools themselves do not rely on that. At first, it was just a game. The idea was that I did the first version of packaged, which was only doing addition. Then I did updates and everything. And I wanted to know how far I could get without needing any index. And then at some point, maybe 10 years ago, I realized, okay, I've done enough. I can manage to do everything without a global index. And so I do not need a global index. And this is good, because this is one less thing that can get out of sync. And on your local machine as well, if you look at an OpenBSD, you'll notice that there is one major difference with other machines, with other operating systems, which is that we don't have an actual database of everything that's installed on the machine. We have a directory, VARDB package, in which you have one subdirectory for each package which is installed on the machine, but there is no global database that says, okay, we have this that depends on that and everything. Everything is very fine-grained, and first it's very resilient because it can't get out of sync. There is a small price to pay. Sometimes things could be slightly faster. We are working on that, and there are some solutions. And this decision has some consequences. Some intractable consequences, actually. We have snapshots which are about 30 gigabytes. With the tools that we have these days, you have one new snapshot every 2 or 3 days for major architecture. Of course, you're not going to get a new package snapshot for Spark 64 every 3 days. That would require probably 200 Sparks or something like that. No, not efficient. So when you upload a new snapshot, you are going to get into a sharing problem. Like at some point, you're going to have some of the new packages already transferred and some of the old packages which are still there and are in the process of getting updated. So this means that the solution that we currently have, that each package is independently signed, is the only possible solution. Otherwise, you would always, if you had a global signature like a manifest for every package and the checksum of every package recorded at some point, it wouldn't work, because all the time you would end up with discrepancies, like some of your package are, I don't know where the signature is and everything. There is no other solution, in fact. Like I said, there are some drawbacks to this way of doing things. Some limitations for the model. Everything we do is based on package names, because when you are going to do an update, you're not going to go into that package directory and look at every single file. There are something like 9,000 packages on the FTP site these days, I think. So we have to have consistent package names. Sometimes this doesn't happen, so yeah, we don't have an index, but we have an escape mechanism called quirks, because sometimes we want to rename stuff, not too often, hopefully. And then we have to open each package to check further whether it is indeed the right update, whether there is some weird stuff that's going on or not. Packaged itself doesn't do it because it can't do everything. It's still lazy. So we use the FTP command these days, which contrarily to what it says, also handle HTTP and HTTPS. And that becomes a problem, because it can be slow. For instance, these days, we have a very minor problem, which is that you are supposed to use packaged on HTTP repository, and you can use it on HTTPS repository, but it won't be so good. Because each connection to the repository is going to be a separate connection using a separate FTP command. Due to limitation of our libTLS and some design decision in FTP, it means that every single FTP is going to have to re-authenticate with through HTTPS to the distant repository, and it costs a lot. I said this is a minor problem because we have signatures which are completely independent from HTTPS. So whatever happens if you connect to a fraudulent repository, well, you will get packages with bad signatures, and that's it. Packaged will stop itself right away. We shouldn't trust FTP itself, and we don't. At about the same time that we changed signatures, we also added some level of privilege separation to package apps so that FTP is actually run as its own user who can't do anything on the system. So that's perfectly fine. So it's just a minor problem. The issue being that if you are using packaged on your OpenBSD system, there is still one small security implication. Yeah, I think that you are falling asleep, so what's the security implication?
You're leaking the package you're installing.
Right, we are leaking the packages we're installing. Yeah.
If the hacker decides, well, I know there was a security update for this package, then he can supply the old package indefinitely and new versions for others and leave your security hole in place.
Yeah, that's also a valid problem. The problem being that if a hacker decides to keep a copy of an old repository before there was a security update, then potentially there could be some trouble, but we took care of that. Like you have the Quix package, every package, if you remember one of the first slides, has got a timestamp, right? And whenever you do an update using packaged, it will display the timestamp for Quix, which is the main package with everything useful, every meta information for the whole repository. So you have to read, because we don't know at which rate snapshots are updated, and it depends on the architecture. But you will see that your Quix dates back from that time. So if you have a real old Quix, it usually means that something wrong is going on. And then inside Quix itself, you've got a list of packages with security holes that have been updated since then. And during the upgrade process, if packaged can't find a newer package for one of those with security implications, then it will tell you that there is a problem. So yeah, that's definitely a theoretical problem that one we solved. Yep.
But you're still relying on the fact that you have a decent enough Quix package.
Yes, I'm still relying that I have a recent enough quirk, but I can't do anything about that. Like, what's recent?
Yes.
For MD64, 3 or 4 days is recent. For Spark 64, 6 months is recent.
3 weeks. Every 3 weeks.
Okay. Yeah, well. But, yeah, you have to engage your brain. We are talking about security. It's not Windows where everything is insecure by default. But if you don't look at what the system tells you, you're going to run into trouble. Oops. Okay. Too much, as usual. I'm just going to finish with very recent stuff, which became part of OpenBSD package systems about less than a week ago, and which is called version. I was talking about package names being an integral part of OpenBSD, and sometimes we do system-wide changes. This happened a few years ago when we changed type def to unsigned long across all architectures, and this broke C++. Yeah, because name mangling and everything, and if you change the actual type name, so every function name changes, and you have to bump to change the specific patch version of every package depending on C++. And then more recently, we switched on to minor architectures from GCC to Clang. And this breaks all C++ again. Maybe there is something wrong with C++ after all.
Yes.
So we did bump every package the first time. The people who helped doing that are still scared by it. We don't want to do it again. So this time we decided, okay, we're not going to do it. We are going to tell people, well, fuck you, I don't like you, and you have to update everything by hand. Force an update. And then Stuart, who is a very smart guy, convinced me that maybe I should try to find something else to do. And at first I thought, I'm not going to do that because basically I need to put base system dependency somewhere. And I hate that because I'm going to end up with a file in source that I will have to bump from time to time, and I'm going to run into TO all over again, which is a problem because when you get two heroes in front of each other, they fight usually. And in the buff, I realized I was going at it all wrong. Like, I don't need at all to have a dependency on the base system. I can put it directly inside the package. And first version was born. Like what we have right now is that each package has got a kind of serial number that gets bumped inside the package system proper, without any reference to the source system, and without any dependency to external stuff. It's very simple, like if you have a package that says version 0, and then you look at the snapshot and you see a package that says version 1, okay, that's a new package. I just update. The way it's built, it's be strange. We have a flag to package create, which is -v, where that you can use multiple times to build a version number by adding numbers together. The idea is that it's very simple to do that without needing any make magic, so that you can have machine-independent parts and machine-dependent parts in the same makefile. Like currently, you have the whole OpenBSD system, which is at version 0. And then when you run AMD64 or other Intel processors, it goes up to 1 because of the second -v. And it turned out to be incredibly simple. Like, if you look at this patch, for the amount of code I had to change, it's about 20 lines, all considered. And it changed everything. Like, now we have a mechanism that was used to move to GCC to Clang seamlessly. Like, if you're running OpenBSD stable and you move from 6.1 to 6.2, you won't notice, hopefully, that we change compilers, especially the package system. Well, you will notice that you will update almost every package, but that's it. And it can be used again in the future without needing anything more. So that's really cool in the end. Yeah, well, I was a bit long, so I was also going to talk about the future. But I don't think I have any time for that. So, yeah, maybe another talk next year. Thank you. And of course, I'm going to take questions, if there are any.
We have a second line.
Yeah.
No,
No, but I can talk in this one, maybe,
Yeah,
for once.
Yeah.
Any questions? For those of us running snapshots on OpenBSD, are there any ways we can make our lives easier? Sometimes I'm in the situation where I installed a version of userland, and it turns out the snapshots of packages are not yet updated, so I have to wait 12, 24 hours. Is there any way I can know beforehand that I'm not blowing my system away for the next day?
I'm afraid that we don't have enough human resources to be able to help you on this one. Like, the most we could do is to get the turnover to be faster, which we already did. But basically, being able to inform you that when the snapshots are going to be online, it's just extra communication, which takes more time. Like if you do this stuff, you're going to have to wait for a few more hours each time, probably. Also, I think that there is some paranoia involved. Like some details of the signing process are not completely public, who's signing, on which machines this is done. And we don't want to leak information concerning that. Sorry.
Well, maybe I can reply to this question. Everyone has his own axe, and you can just follow the CVS commits, see when the library gets bumped, for example, and you just compare with what's on the mirror right now, because as Marc told, you can extract the package and look what's inside, and you will see in the signature if it matches what's in the package will match what you will have on your running snapshot. So maybe you can download the snapshot, look at the last library when it was bumped. In the case of libraries, when you have breaking change in the kernel, of course it won't work. But then you can compare that the snapshot will match the libraries which are in the packages. And everyone has his own axe this way.
Actually, there might be a solution, assuming the kernel doesn't change too much, because you will be fucked then, obviously. You could use the tools that we use to build ports, proot, in a shroot. You can use it to populate an area of the disk with a snapshot, for instance. And then you go into that area and you could try to do a package add -n there to check whether or not it will work. That's a bit intensive, but at least there's almost no human intervention. You probably can do that with a shell script that would be about 20 lines long, but it will be slow.
Anyone else?
With these package versions, do you bump them manually? And do you bump the version for all packages or only for that are affected by some GCC plus or C++ update?
The idea is to bump everything system-wide, more or less. Like we have this mechanism that some people objected to, but we are very happy to have these days, which is that you can have arch-independent packages, package arch equal to star. And basically, I use that to not put any version in my packages, because I know that those packages are just text files, more or less, and because they are independent of the architecture, and everything else got bumped. It's a question of being safe, better than sorry, because you already have dependencies where you more or less know that most packages that depend on Clang have been updated. Like if you depend on the C library, on the C++ library, of course you're going to get bumped. But it didn't catch everything. So we just decided to bump it all. We don't have enough human resources to check every single package that there is compatibility.
But I got it right, the package with the Arch star are not updated by the version.
Yeah. Okay. Yeah, there is no version in those packages. And this mechanism is actually somewhat more generic. Like if we want to add another part to the version part, we could. There's a question over there.
Yeah, perhaps it doesn't really fit the model, but if you have reproducible builds, then you might be able to say, well, I'm rebuilding this package, but the result is the same, so there's no need to upgrade.
Well, we try to have reproducible parts for lots of stuff, but actually it deters from security. If you look at a recent OpenBSD machine, you'll notice that it does running its kernel in random orders, it running some libraries in random orders, and we try to add some randomization so that some kind of exploits are more complex. So reproducible builds, yeah, that's nice goal when you are trying to debug stuff, but it's more complexity, because then in an OpenBSD setting, you will have to have different switches, so that sometimes you build reproducibly, and other times you have more security. And that's, well, there are bugs, and you're going to run into them. I have a very specific sample of a recent problem that we had to fix after we switched to Clang. On almost every OpenBSD executable, you've got an OpenBSD specific section which is called OpenBSD random data, which is mostly used to seed the canary generator for stack protection and everything. And Clang, which is a bit stupid, just decided that because it's a section it doesn't know about, it's out to be filled with zeros. And we had to fix that. And this was completely out of the blue. Nobody who worked with Clang noticed until, I think it was Theo himself who noticed that it was the case. And if you do reproducible build, then you lose some of the security features that we have. And if you do that as a switch, then maybe you will break something and you will notice 6 months later, like this happened for some of our OSs, that BSD Vex. So, yeah.
Okay. All right. If there are no further questions, I'd like to thank Marc for your presentation. And
thank you for listening, guys.